Let's now calculate the resultant of two forces whose point of application is the bracket. So this would be F1, and we'll trace F2 this way. That's F1 and that's F2. So F1 could be corresponding to a class 2 elastic and F2 to an intrusion force with some distal component. The second step will be to trace the X and Y coordinates. We can use a ruler for that. We are on Y right now, so we're going to trace the Y axis and then the X axis. Let's move the ruler to the point of application of the force, make this as parallel as possible, and we're going to get the X axis right here. That's the X, that's the Y. Now we need to find F1X and F1Y and F2X and F2Y. So let's use the ruler again. So make a parallel to the X, which is going to be this point right there. We can do the same thing for F2 on the Y-axis, which is going to be right here. Then we rotate the ruler and we bring it to roughly this point. Which becomes the F1X, and we move this to this point, which becomes so now you have F1X right here. We have F1Y right here, F2Y, and F2X. The way to calculate the magnitude is now to do an addition to get FR equals F1X plus F2X, which is FRX, and FRY equals F2Y plus F1Y. These are the magnitudes of forces that we now have. So we can add these two together and it will give us a point on the line roughly here for the FRX, and because the F1 is negative, you will have to subtract from F2Y from F1Y, and you will get roughly this point. We're going to remove this a little bit so we can better understand. This will become FRY. All we need to do now is, again with a ruler, determine the new force system by making a parallel to the point in the y-axis, and this point represents the end of the arrow that we can now trace using, again, a straight line, and probably using a different color again. Let's use red. And this will become our new arrow, which is the resultant of F2 and F1. So FR right here, FR is right here. Using simple trigonometry, we can now know that FR square equals FRX square plus FRY square, or FR equals square root of FRX square plus FRY square. Now we know that the magnitude and direction of the force. The issue now is we do not know the angle right here, which we call alpha. So how to calculate alpha, or how to calculate the slope of FR? Well, the slope of FR is a ratio between FRY to FRX. We'll give you a value which is equal to the tangent of alpha. Once we get the tangent of alpha equal z, we can go into the tables, look at the value of z, and you will get the value for the angle alpha. So now by these simple calculations, we know the magnitude of the force in the x-axis right here, in the y-axis right there, which allows us to get the magnitude of FR by the combination of these two forces at the bracket level, and by a simple trigonometric calculation, which is tangent of alpha equals z. Z in the table gives us the angle. You can also use reverse tangent, and it's actually does both calculations at the same time. But for now, using tangent gives you a better idea. So just by looking at F1 and F2 and doing these calculations, you have the exact value for FR.